Hi, I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, October 25th. Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Niño, weather analysis, real data for outdoor people, all the time, no hype. Looking at significant wave heights for the North Pacific Ocean, we see a low-pressure system generating south winds and seas at 18-19 feet, but all aimed at Alaska, and a little local fetch off the northern California coast producing 13-foot seas. But other than that, nothing of any real interest, at least for the moment. As usual, we'll start looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they do form, help direct their track. We're looking for a trough that is a dip in the jet, just like we have right there. And what that does is create a counterclockwise flow aloft and down at the ocean surface. And if that flow is strong enough, it generates winds, and winds generate seas. If they're strong enough, seas, if they're high enough, produce swell as the seas radiate away from the fetch area. And that swell, when it hits your beach, turns into surf. All right, you will also notice this is the plus 42-hour forecast from a model run. What was that, 2 days ago? NOAA is having issues at their data center. You'll notice a bunch of our charts have not been updated. All the weather models are 2 days old. NOAA is working hard it's actually the National Weather Service. They're working hard to resolve it, but there's some major outage, communication outage at their data center. And so nobody can get access to the latest data reasonably, so hence the older data. But in general, it's good enough for our purposes for this evening's discussion. All right, so jet stream with a trough northwest of Hawaii, but the trough is pinched. See that very tight coupling here between the downward falling western portion and the upward northward traveling eastward section of this trough. That's not good to support gale formation. You need more space in there, even though the winds are good at 150 knots falling into it. And hence, you notice there's not a whole lot of sea production in that area. And if anything, the trough only is to get more pinched as we move into Monday, and then just basically withering out. But also notice wind's still pretty solid, 170 knots, pushing over the date line as we get into Tuesday, and then a new trough starts building here off the Kuril Islands on Wednesday. Sort of a generic kind of trough, not real deep. In fact, if anything, moderating as we get into Thursday. But notice wind energy starts building off Japan on Friday to 190 knots, feeding a new trough supposedly on Friday into Saturday. And then that's the end of this model run because, again, we're running about 2 days behind. All right, let's go take a look down at the surface. Here we are, surface level pressure, surface level winds. You see south winds, 30 knots in one spot. But so remember, there was a trough here. You want to see winds falling down into the trough. We don't see it. We only see the upside of the trough and everything aimed at Alaska, so no swell generation potential. Also notice these winds off of Northern California, 30-knot winds, actually generated decent wind swell at select breaks in Northern California today, you know. Some peaks, maybe a bit overhead. The bars are not in good shape because there hasn't been any significant swell to break anything up, so it's kind of death closeouts, but hey, you take what you can get. All right, so moving into Monday, that fetch. Now notice, when that fetch fades out, that's the end of the wind swell for California for the foreseeable future. But also notice, low pressure system is forecast to develop on Wednesday off Japan with building winds to 45 knots Wednesday morning, lifting northwest, and 40 knots aimed at Hawaii on Wednesday afternoon, continuing at like 40-45 knots. According to this model, I think this is a little bit overhyped. It's backed off since then into Thursday and then Friday and fading out, and then theoretically another one behind that. All right, let's go look at the wave models. Let's go see the effect of these winds on the ocean surface. We're actually going back in time a little. We're going back to Wednesday evening, what was that, about 3 or 4 days ago, because a small gale did develop over the North Dateline region with 31-foot seas. This is down here, see that? 34-foot seas is the highest seas anywhere on this in this area bounded here, and then you actually get the coordinates so you can confirm, especially if there's multiple systems in flight. So right on the date line right there at about 45 north, 45.5 to be exact. 34-foot seas, we'll give it 33-foot for general sense. And then it pushed across the date line and faded swell from the system. There's Hawaii down there. Maybe we can actually, oops, no, this is hindcast, that's right. And swell from that system is hitting Hawaii now. There's actually some decent waves there, and I don't know, top spots, couple feet overhead, lined up and pretty uncrowded, not bad. Swell from that system is also radiating towards California. It will be much smaller in size when it gets here because most energy was in closer proximity to Hawaii. And it's a rather northerly direction, so it'll mainly be a north of Point Conception event. Nothing significant. All right, let's go take a look at what's to come in the future. Here we are today. We saw this already. The system there fades out. We're looking for a gale. There we go on Wednesday off Japan, building. This is a little bit downgraded from previous runs. We're into Thursday morning, a little tiny area of 30-foot seas, and then building to 33-foot and 34 feet on Thursday evening into Friday, pushing over the date line, falling into the Gulf with 28-foot seas on Friday evening, and then fading some from there, maybe regenerating. Hard to say. This energy, secondary energy, looks like it's aimed well at Hawaii. That fades out. Another system develops off the northern Kuril Islands, 22, 23 feet. Whoops. And then that one fades out. But you almost get the sense that, hey, we're starting to finally move into a fall pattern. And even this one, you see, what is that, maybe 15 foot? Well, we'll actually do this here. That's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17-foot seas in the Gulf of Alaska off of California on theoretically a week from now, Sunday night. So that would make for decent-sized surf into maybe most of California if this develops as forecast. A little bit of a reach seeing how it's a week out, but hey, gives us some hope. And then looking down south, this is Sunday, this is today. A gale is trying to organize in the deep south central Pacific. By Monday, theoretically 35-foot seas. California's, the eastern edge of the Southern California swell window is about 117, 118 west, right about there. So, and you see, up to 37-foot seas before they push out of the California swell window, but all this is aimed well off to the east. Yeah, some sideband swell will reach up into Southern California, but not a major swell-producing event. Now, this system, here we go. This is looking better. This system was, maybe Wednesday or so of last week. It popped up on the models out of nowhere and forecast to have like 50-foot seas, and then very next run of the model it almost disappeared. Now it's back, forecast with 42-foot seas and aimed well off to the northeast. This is on Wednesday evening of this coming week. If this were to materialize, you definitely get a solid push of southwesterly swell into California if that materializes. Bit of a reach still, but not completely out of the question. And then perhaps the southern hemi starts to fade as the northern hemi starts waking up. Looking for wind swell or wind swell potential. Now remember, this is an older model, 42 hours ago. Again, the National Weather Service, we've gotten an email from them. They're going to be hot on this Monday morning. Hopefully they will resolve it, but we'll see. Anyway, north winds off California produced wind swell for California. Not a whole lot. I mean, just light, spotty 15-knot trades for the Hawaiian Islands. It's really the north swell there that's going to be the function for the next day or two. 30-knot winds forecast again off Cape Mendocino on Monday. This is what they're talking about in terms of fire danger, this offshore flow. We'll see how much that really materializes. And the main event is supposed to be, I believe, Monday morning, like 1, 2 a.m. So we'll see about that. Anyway, winds start dying as we get into Tuesday. And theoretically, after that wind event is over, wind swell potential for California all but vaporizes. Notice low pressure building in the Gulf of Alaska. We're hoping that is true. Model only goes out till Saturday, but you see a generally light wind pattern is forecast for the foreseeable future once we get over the immediate northeasterly winds. Rainfall potential for California right there. We're watching it. There's literally just 1030 millibar high, just locking everything down. The snow line, I think there's pieces of it that have made it as far as maybe Oregon, but really Whistler is the only thing we've seen that has any significant snow added over the earlier this week, and maybe it was Friday they got, I don't know, 8 or 10 inches, something like that, in the higher elevations, and more forecast behind that, but California, high and dry. Snow forecast potential is for Squaw Valley, nary a drop to be found. Temperatures so the snow line here, about 12,000 feet, and bumping up a little bit on October 27th and 28th, and then falling back down to about 12,000. Did I say 27? 12,000 feet, 12,000 feet. So no real clear sign of deep, cold air getting down to lower elevations just yet. I mean, it's just going to be a late start to the season. That has been the hallmark of this La Niña year. But then we do want to turn your attention to what is Hurricane Epsilon off the northeast U.S. coast here. And you go, okay, well, why do we care about that? Well, every now and then you get these hurricanes that they hit the jet stream, they get supercharged, and it happens in the Pacific too, and they explode. And that is what is forecast to happen as we get into Tuesday. Right in here, watch this, right there. 64-foot seas taking aim on all of Europe down into northern parts of Africa. This is seas. This is not surf height. This is not computed surf height. This is just, the scale ends here at 52, and then you have to start counting the lines or just read it down here. But 64 feet, and then pushing directly into Ireland with 48 to 50-foot seas impacting the coast there. Probably a washout, out of control conditions there, but as you get down into these areas, significant swell, and you can see the seas just pouring into this area. Something to keep your eyes on if you're a weather junkie for sure. All right, let's go take a look long term. What's going on with the MJO and then, of course, La Niña? As usual, we start by looking for the presence of the active phase of the MJO. The MJO's weather pattern travels on the equator from west to east around our planet. The active phase is basically like a low-pressure system. When it's traveling on the equator across the Pacific, it creates precipitation, it stomps on the trade winds, which is actually a good thing. It imparts energy into the jet stream, feeds energy into the jet stream, which then helps feed the storm track, which helps produce swell and weather and snow and rain and all the good things that we're interested in. The inactive and the active phase takes about 3 to 4 weeks to make it across the Pacific, and then it's followed by the inactive phase. The inactive phase does the exact opposite. It just kind of, it's high pressure, it doesn't promote storm production, and when you have a La Niña base state in play over the Pacific, and the inactive phase moves over that La Niña base state, it actually feeds La Niña and does the exact opposite of what we do. It just feeds high pressure and stomps on storm production. All right, so first up, we're looking here at data from the TAO buoy array series of buoys strung across the equator used for monitoring El Nino. This is the East Pacific here. This is the West Pacific here. 0 degrees, that's the equator. The date line, 180 west. What we call the Kelvin wave generation area, this area in the far West Pacific from 170 west, 5 degrees north and south of the equator. That's New Guinea right there, by the way. When you get the active phase of the MJO over here, it stomps on trade winds and feeds the jet stream, and that's exactly what we want. And if it is strong enough, it reverses trade winds, can actually create a Kelvin wave, taking warm water in this area, pushing it off to the east. If you get successive strong active phases, that can kick off El Nino if it's in like the January, February, March time frame. Right now, we're looking at winds strong from the east in the East Pacific. We're just looking at the arrows, the length of the arrows. Strong from the east over the Central Pacific. Strong from the east over the Kelvin wave generation area. No signs of the active phase of the MJO. Keep that in your mind. But it's actually anomalies, the differences from normal for this time of year. And even with these strong arrows, you see little baby east arrows in places here, suggesting these are, in fact, stronger than normal. Building a little bit more over the Central Pacific and even more over the Kelvin wave generation area. So no sign of the active phase of the MJO. Then we can look at the hindcast, what's been going on for the past month, and the forecast for the next week. So this is the whole planet on one chart. 180 west, that's the date line. So the Kelvin wave generation area starts about 135 east, goes right up the chart there, and goes to 170 west. That's the area we're interested in. That's the area that feeds energy to the jet stream. The blues and the purples are easterly anomalies. Consider that the inactive phase of the MJO. So only in the Kelvin wave generation area, that's what we're interested in. We see all of September, all of October, easterly anomalies in control. The good news is, just starting today, those easterly anomalies are breaking up, and we're getting a little hint of westerly anomalies, the yellows here, building in the Kelvin wave generation area. Maybe a hint of at least some weak active phase of the MJO. While easterly anomalies, though, are forecast to hold east of the Kelvin wave generation area, that doesn't really do a whole lot. It doesn't stomp on storm production. It's really this area that matters. And so it looks like we're moving into a somewhat more favorable pattern now for the next week, and the wave models sort of suggest that that is in fact the case. We're going to get some activity. Next up, we go out 2 weeks. This is another MJO model, the outgoing long wave radiation. Fancy word for cloud cover. The blues, negative anomalies, meaning less sunlight reflectivity off the ocean surface. That means more cloud cover. Then can be loosely associated with the active phase of the MJO. All right, the equator is right here. See South America, Central America, Australia, New Guinea. Kelvin wave generation area right there. Active phase of the MJO then is over the Kelvin wave generation area. That's what we want. But remember, we saw in the previous chart, easterly anomalies. We should be seeing westerly anomalies. That is strange. Anyway, this per the statistic model, active phase of the MJO forecast holding almost nonstop for the next 2 weeks. That would be a good sign. The GEFS model, the dynamic model, saying, well, it really only holds for about 5 days and it fades, and then the inactive phase shows up about 2 weeks out. So maybe that first model is a little bit optimistic. So let's inspect the active phase of the MJO. These are what are known as phase diagrams, one for the statistic model, one for the dynamic model. What are we looking at here? See that circle right there? Assume that is the North Pole and you're looking down on the North Pole, and the MJO moves on the equator, oops, there we go, like that, out around the edges of the planet on the equator. So from the Indian Ocean to the Maritime Continent, over the West Pacific, over the East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. Where the heavy dot is where the active phase of the MJO is. So somewhere between Bali and the West Pacific. And that's about what we saw in the other charts. The further the dot is away from the circle, the stronger it is. So we'll call it a modest active phase of the MJO. And these are 3 different forecast tracks. One saying, hey, it might actually strengthen and push into the West Pacific. And 2 others saying it's just going to crash and go into the East Pacific. That per the statistic model. Dynamic model says, active phase for the next 1, 2, 3, 4, 5, 6 days or so. Hanging, meandering around in the West Pacific, then getting weaker and crashing and almost non-existent 2 weeks out. So then we go to the upper level model, okay? So each one of these is a frame, 5 days between each frame. South America, Central America, the equator right there where it says 0. Okay, New Guinea right there, Australia. So the Kelvin wave generation area roughly right around in there. The greens are areas favorable for precipitation, so that would be the active phase of the MJO. And we know that the active phase of the MJO is in that area right now, but we also know that it's not generating westerly anomalies as one would hope, more like just neutral anomalies or maybe even easterly anomalies. Weak active phase is forecast tracking. You can follow the greens pushing into Central America about November 19th. Inactive phase, this area, the yellows and oranges are areas not favorable for precipitation, so we equate that with the inactive phase. That's supposed to move into the West Pacific Kelvin wave generation here about 9th of November, make its trek across the Pacific through about, December 4th? And at that time, the active phase is forecast building in the West Pacific. So this would be early December. Let's say here, for the next week and a half or two, favorable for storm production, and then things falling apart, and then maybe starting, early December or so, things wake up again and maybe go good through Christmas, we're guessing. Then we go out to the 1 month CFS model. Now, this is an interesting chart here, all right? So again, it's the whole planet on one chart. Kelvin wave generation area starts here about 135 east. And goes to 170 west. That's the date line right there, 170 west right there. Solid contours are the active phase of the MJO. So, and here's where we are today. So, the active phase making its way, it's really continuous. The chart doesn't quite have it right, but making its way across the Pacific, starting, about a week ago. And it'll be out of the Kelvin wave generation area by about November 7th. But notice the blues are easterly anomalies, a little hint of westerly anomalies. So what is going on here? Why is the active phase not producing westerly anomalies and not pushing energy into the jet stream? Well, you can see this purple line here. It's the low pass filter. It's the La Niña base state. So La Niña is in control, has more power than the MJO. It's producing easterly anomalies, and even with the active phase pushing over the Kelvin wave generation area, all it's doing is tamping down the easterly anomalies, not generating westerly anomalies. Now you notice down here as we get into November, this is the inactive phase of the MJO, and when it moves in and syncs up with the La Niña base state, easterly anomalies are to build strong, and that will just crush storm production around the Thanksgiving time frame. So something to keep in mind. Then we go even further out. This is the same deal, one of these charts, but it's reversed. Past performance is down here. The forecast is up here. The thing that really catches our eye, a lot of westerly anomalies. Where is the Kelvin wave generation area? It starts right here. So it's not till the Christmas time frame that westerly anomalies are forecast moving into the Kelvin wave generation area. But you see here in the eastern Pacific, strong easterly anomalies are supposed to just be raging at that time. So that would suggest a lot of high pressure, a lot of probably not favorable for precipitation conditions in California. All right, let's overlay the MJO, see where we're at. Here we are today. Here is our, wrong one right here. There we go. All right, knew it was looking a little strange. So here's our active phase of the MJO. This is down at the 850 millibar level, which is about 4,700 feet up in the air, which is, good enough to give you a rough idea. Active phase of the MJO through about, November 8th or so, something like that. Okay, pockets of westerly anomalies, but in the Kelvin wave generation area, nothing solid. Then here's your inactive phase of the MJO. That starts about, we'll say November 5th and continues into about December 4th. Big, strong easterly anomalies in control. That's not good for swell production. But then as we get into, right after Thanksgiving, the active phase supposedly is to build, and it's supposed to continue the whole way through Christmas and beyond with westerly anomalies in control, producing surf for the Pacific Ocean. Theoretically, and even with the inactive phase moving in towards the January timeframe, still westerly anomalies in control. Now, we never believe a model even 5 or 6 days out, much less 3 months out, but it gives you sort of a rough idea, at least of what is forecast to happen over the coming 3 months. Take it with a grain of salt, but it gives you a hint. All right, so enough of the MJO discussion. Let's go to the even longer term, the La Niña El Niño discussion. Let's see what the ocean is telling us in terms of what it thinks is happening. Okay, this is the East Pacific here. This is the West Pacific here. This is the equator, and these are the anchor lines on the TAA buoy arrays. The X's are sensors on those anchor lines. Those sensors relay data up to via satellite to a central processing facility, I think in Maryland. And then you apply a model to it and you get a profile of the subsurface ocean temperatures down 100, 200, 300 meters. It's really the top 150 meters that we're interested in. The 29 degree isotherm line, this is warm water, centigrade, okay, is in the far West Pacific, about where it's been at 163 east. The 28 degree isotherm, right on the date line, no big change since last week. And the 24 degree isotherm, well, it was over about 135. It is backtracking. You notice all the warm water is in the west, and whatever warm water there is, it's very shallow and not as warm. What's going on here? Well, we know we have easterly anomalies blowing from this direction to here across the equator, and they're just scooping all the warm water and pushing it this way, carving out cooler water in the East Pacific. In fact, let's look at the anomalies, differences from normal for this time of year. That tells the picture. Warm water, 1 degree above normal, limited to a little finger that is going nowhere on about the 165 degree line. That's where it's been, a little bit south of Hawaii, let's say, a little bit southwest of Hawaii. Cold water, 1, 2, 3, almost 4 degrees centigrade below normal. So what's that, about 6 or 7 degrees Fahrenheit below normal, filling the entire East Pacific, even across the date line, even into the West Pacific. Classic La Niña sort of pattern. You want warm water here. And warm water, why? Because warm water creates evaporation. Evaporation transmits energy up into the atmosphere, and then that creates storms. But when you have high pressure creates the easterly anomalies. It's stable. It locks things down. You get cold water. So the more cold water you get, the more high pressure you get, and they start feeding each other. And then when you have high pressure and cold water on the equator, you get no precipitation north of south of there, like into California. So where's 120 west? Like right there. And that's right at, 120 to 130. That's the peak of the subsurface cold water. That's not good for our coming winter. Upper level model, I'm sorry, not upper level, a different model, a high res model showing basically the same thing. West Pacific here, East Pacific here. Blues, colder than normal temperatures. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 5 degrees below normal temperatures, and everything else 1 or 2 degrees below. Cold water in control of the entire East Pacific. You got the picture. Not a pretty one at that. All right, ocean height anomalies. Just another way to verify temperatures. This is South America here, Central America here, Mexico. Minus 15, minus 20. What's that mean? That means the ocean height is 15 to 20 centimeters lower than normal. Why would it be lower? Well, if you have cold water contracts and it creates a divot on the ocean surface. That's what we're seeing here. And you notice cold water is up into North California, out past the intersection of the equator and the date line, the whole way down into Chile here. And this is the classic La Niña signature. Then upper ocean heat anomalies. This is just a way to sort of look at the evolution of this over time. We have time here going back a year, November of 2019 to late October 2020. You can see it plain enough. The reds are warmer than normal temperatures. Our last Kelvin wave right in here started last December into February, limped across the Pacific, and then starting about April, the cool regime set up. So in a really good year, you'll start to see the beginnings of El Nino or La Nina. In a good year, I mean in a strong El Nino, La Nina in the February time frame. April, a little bit more moderate, but we started to see this La Nina signal, a bit of an incursion of warm water. not even qualifying as a Kelvin wave, and then you see deepening cold water. What is this? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2 to 2.5 degrees below normal. And clearly the trend is for cold water. Well, their date line is right there. You see warm water building in the west, but we got a ways to go before that overtakes anything. Cold water in control. So then we go take a look at the surface, and a bunch of the images that we normally show, they're down too. We're assuming, but could be wrong, but assuming that they maybe are impacted by the same outage as some of the other National Weather Service data. But you get the general idea here. South America here, Central America, Mexico, California. The equator, 0 degrees right here. This is sea surface temperature anomalies, differences from normal for this time of year. Blues are colder than normal water. When you see that, that is La Niña, if there ever was La Niña. The whole South American coast, the whole way out beyond the date line. Now, normally it would sort of work its way up into Mexico, and it hasn't done that, but that doesn't really mean anything. And it's just this area, 5 degrees north and south of the equator, that really matter, right in there. Cold water in control, driven by high pressure here and high pressure down here, and between the two of them you get that the trades that normally blow, but because the high is stronger than normal both north and south in the Pacific, it's created more upwelling in this area, and that's how you get La Niña. And it's very hard for a Kelvin wave to make any progress there, or even the active phase of the MJO, so that therefore means it's very hard to get any energy into the jet stream, and et cetera, because the core, the La Niña, the El Nino signal, the low pressure bias, is sitting over here in the Indian Ocean. So this is where all the activity is. This is where all the activity isn't. And you remember that storm we saw poised or forecast for Europe? That's all driven by the low pressure bias being, we'll say, over Africa or maybe the Western Indian Ocean. Sea surface temperature anomaly history in the Niña 1.2 region. This is the area right up there along the Galapagos and Ecuador. Temperatures today, minus 1.353 degrees below normal. Okay, this is not the official El Nino monitoring region, but you can see the trend. Temperatures have held basically 1.5 degrees below normal for months now. But it's the Niño 3.4 region. This is the official El Nino monitoring region. The trend is unmistakable. Down, down, down. That means colder and colder water today. Minus 1.353 degrees. All it takes is 5 consecutive months of 0.5 degree below normal. Okay, we're almost 3 times that below normal. Clear signs of La Niña. Is this a strong La Niña or a moderate La Niña? I think most indications say it's a moderate La Niña, and we're hoping that it doesn't get into the strong category. Let's go take a look at atmospheric indicators now. Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. When you have lower pressure over Tahiti, the index goes negative, like it is today, minus 6.71. So that's a sign of the active phase of the MJO. But you kind of go back day by day, and you go, well, there hasn't been a there was a little batch of negative numbers in there in mid-October, but beyond that, it's been rock solid positive. That's suggesting that the active phase of the MJO has not been very prevalent. 30-day average takes some of the noise out. You can see, yeah, we're at 6.96, and we've actually dropped. We were up at, 12.58 at one point there. So the active phase of the MJO is cutting into that a little bit, but still not a lot. 90-day average pulls yet more of the noise out. 7.51, positive 7.51. We were up at, 8.84 or something like that. So, not horrible. When you're when you start seeing consistently in the plus 12 here and here, you know you're deep in La Niña. But this is a lagging indicator. This one here is at least runs 30 days behind. This runs 90 days behind, or 3 months. So by the time you get to 12 on this one, you're probably deep in La Niña. Anyway, this still generally trending nowhere near El Nino, much more towards La Niña. In fact, we can graph that out right here. You can see, so back April 2019, there's the zero line. The SOI was negative. These downward spikes are the active phase of the MJO. The inactive phase of the upward spikes. You can see this is just a steady upward trend since even, I'll say, October of last year. Our last big active phase of the MJO that was meaningful was October of 2019. Since then, it's been a steady upward climb. Here's our current active phase of the MJO, but we expect we're going to keep going up from there. Clearly, a La Niña trend is underway. So we look at the official Niña 3.4 sea surface temperature anomaly forecast from the CFS version 2 model. All right, mid-October, well, we're more into late October, so that's right about where we are here. And we talked about this last week. This is not the beginning of October. This is mid-October. So a viewer from Britain, I believe, identified that we were reading the chart incorrectly. So thank you for that. We appreciate all input. Anyway, you can see where the forecast is going. Down, down, down. As we get into mid-January, temperatures down to, minus 2.35, something like that degrees. That's pretty cold. But, when they measure La Niña, El Nino, it's not based on an individual daily reading or the peak lowest daily reading. They do it by monthly readings. But still, I think we're going to be down at least in the 1.5 to 1.75 degree range at some month there in January, which is pretty cold indeed. Clearly a La Niña sign. And then you go, oh, okay, well, we'll be returning to normal in July. Yeah, well, that's the ocean getting there. The atmosphere will need 3 to 5 months beyond that. So that's mid-July to August, September, October. Maybe November, we'll see something that starts to look normal in the atmosphere. And I bet you won't even see a normal storm track till you get into almost January. So I would manage one's expectations from here on. I mean, the tropical season in the Pacific for next year, at least in the Eastern Pacific, probably will not be great. Western Pacific, probably pretty good, though. I realized we did not look at one thing, and that was the low pressure bias. Let's go do that. Here we go. Okay, this chart, you saw this before. We were talking about La Niña being the base state in the Pacific, and right there, I don't know, oh, here, maybe I can pull this up. Maybe you can see it, 180, that's the date line. This dotted contour is a high pressure bias over the entirety of the Pacific. The low pressure bias is in, where is that, at about 670 east, which is right smack over the middle of the Indian Ocean. So all this is saying is the reason that there is a lot of easterly anomalies, colder than normal ocean temperatures, is because trades are stronger than normal, driven by a high pressure bias over the Pacific, which is the signature of La Niña. So with all that, what that suggests is right now we're in La Niña. There's no way you can argue with it. And we're going to stay that way probably the entirety of the winter. That doesn't mean there won't be storms. It just means that when they do happen, they'll be smaller than normal. They probably won't be as strong as normal. And the fact that we see the charts just blowing up in the North Atlantic clearly indicates that the low pressure bias that we saw in that previous chart just a second ago is focused more over Europe and into the Indian Ocean and nowhere near the Pacific. So all the activity during La Niña is typically South Africa, Indian Ocean in the summer, that sort of thing, Europe during the winter months. So seeing a megastorm over there on the charts is not a surprise given what we know about La Niña and how this evolves. All right, but the good news is there is a small gale that has passed over the North Dateline region. Decent size, fun size swell is hitting Hawaii right now. Some portion of that energy is going to make it into California. Another gale is forecast right behind that, which will provide surf for Hawaii and into California, and maybe another one behind that. Also down south, one small gale is forecast in the next day or two, with a stronger one maybe 3 days behind that. So southern hemi swell still on tap, especially for Southern California. So all hope is not lost. Looking beyond, though, clearly La Niña is the name of the game. Cold water temperatures for sure at some point, though right now, at least in Northern California, water temperatures are, pretty typical for this time of year. In fact, if anything, we'll get offshore winds. You'll have clean conditions, not a lot of precip, but when we do get surf, it could be clean and fun, and that could be a good thing. So the idea is when there's surf, go get it, make the best of it. Don't put it off and go, I'll wait for the next swell, because you're never quite sure when that's going to be. And certainly when the active phases of the MJO are in control of the Pacific, you kind of want to be on alert and make the best of those when they happen, because when the inactive phase of the MJO lines up with the La Niña base state, that will certainly squash the storm production machine. All right, well, that's it for this week. If you enjoyed the video, give us a thumbs up down there. We'd appreciate it. If you haven't subscribed, please subscribe to get a notification when we post the video. If not, go to stormsurf.com. All the data you saw tonight is available there, and we'll post links to the video on the site there at the top of the page, so you can just go watch the video at your leisure as you see fit. All right, that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.